These are your 9-2B notes. We're going to solve quadratic inequalities. The theme is the same. You're going to find your x equals negative b over 2a value. That'll be the x coordinate of the vertex. You're going to make a table of values of 5 points. You're going to graph the 5 points. And then we're going to just add on a little bit more. So we start off by graphing the related function. Then after you have the function graphed, we determine whether it should be solid or broken. I'm not sure why this didn't show up. Okay, and if you remember, we did this. More than one answer that can happen. And so we have to decide. So if we break it, that means it's less than or greater than only. Be solid if it's less than or equal to or greater than or equal to. And that just basically says, do the ordered pairs that we use to create the function, do they work or do they not work in the inequality? And it all boils down to that equal sign. You're going to pick a point not on the graph to check for shading. 0, 0. Okay, not always. You can only use 0, 0 if it's not on the graph. And then we always shade true. And so that's the extra 2 things we have to do. We have to break or not to break. Rather than saying shade above or below a line, solutions lie. So this is how you answer quadratic inequalities. You can't give me one answer. I can show you a picture and say all of this shaded region represents my solution. Go ahead and try this. We get y greater than or equal to x squared minus 5x plus 4. So the first thing I'm going to do is I'm going to figure out my negative b over 2a. Since my b is negative, my negative b will be positive over 2 times 1, which equals. So my vertex is 2.5. That's my. I plug 2.5 in for x. If you're having a difficult this, so I'm going to put the parentheses into the calculator. I'm going to square 2.5. I'm going to subtract 5 times 2.5. And I'm going to then add 4. You should get negative 2. That's my vertex. I'm going to use my to the left of the vertex. And so when I plug in one of those values, I can plug it's also going to give me 10. So these. And your y values get instead, maybe. And everything we've done so far is a repeat of what we've done. So now side I shade solid that all to this value right here, my inequality. Since there's a line underneath it, it means that these numbers work. You do not have to pick on the graph. And I'm going to check it. Use zero because zero is a number to plug into the inequality. It's easy to plug in. I cannot use 0, 0 if it's clearly not on it. And you also don't want to use points that are kind of close because we don't know. Right now on my sketch, it's in the interior, but it's so close. What if it's just on the interior because I graphed it kind of messy? So don't pick points that are so close. I think it's safe to say that 0, 0 is clearly on the outside of my parabola. So 0, 0 is going in to the function, and it's going to represent every single. Okay, so if I'm going to check 0, 0, I'm going to plug it in. It's nice when you use 0, 0, everything disappears. If 0 is not greater than 4, that means solutions are inside the parabola. And so I'm going to shade inside the parabola. Okay? To shade true. Now I know I didn't get a true result because I didn't pick a point that was inside the parabola. If you really want to get that true point, go ahead and pick any ordered pair that's in the interior, plug it into the inequality, and it should give you true. So I say shade true. If you get false, that means the opposite spot is another one. So we're going to go ahead and figure our stuff. X equals negative b over 2a. That means x is equal to negative 6 over 2 times negative 1. Nope, sorry. So negative 1 is 6. My vertex is at 3, 6. I suggest at 3. And so you have to the left helps people. I'm going to use my y-intercept. My y-intercept is negative that, and I realize that negative 3, 0 of the 5 points. So do you see my gap? That's 3 units away. Table can take shape. So I don't want to make sure you get symmetrical. See all my consistent. It's true. Yeah, that's good. I look at my inequality. Inequality is, and so it's going to be broken. Still use 0 is still on the outside. The broken. So I didn't get to show you one where we shade true. I apologize. And I want